Okay, so we have the solution for this over here. Now what I'm going to do is I'm going to create one more just to have a side-by-side comparison. Okay, for I already have for test that I'll do the same thing for train. Try to predict out on train also. Pass train over here. Okay, I have two things to compare out. Now what I'm going to do is I am going to evaluate our model first on the training set and then on the evaluation, and we will look if we are getting solutions, the solution something like this. Okay, so first of all what we need to find out is we need to find out the r square error. It is the r2 score. So let's print matrix dot r2 score, and let's first of all do in the training set. Okay, we are going to pass y train, and then we are going to pass our y train pred. Okay, which gives me 0.799, exactly the solution we had before. Okay, same thing if I do it for the other. Okay, the next one is mean absolute error. So we have, again we'll call matrix, then mean absolute error, and inside of this we are going to pass this. Okay, getting on the same solution as below. Then again from matrix I am going to call out the next thing is mean square error. So we have mean square error, pass it inside of it, getting quite a good value, right? And then we have the root mean square. Okay. For root mean square, what we can do is we can just do np dot sqrt square root, and then we can pass out the mean square error. This is for training. If you compare the solutions, see I am getting almost the same one. Okay, almost the same thing as we were having it before. Okay, now if you want to plot a graph, you can easily plot it out. Plot dot scatter. I'm gonna pass. First of all, I need to pass my y pred. Okay, I'm gonna pass y. Let's pass y test, and then I'm going to pass y. Sorry, y train, and then I'm going to pass y train pred. See, we are getting quite a straight line over here. That was on my training set. The same thing I'm going to do it on my same thing I'm going to apply for the test set. And the only difference that I have to create is I have to pass x test over here and x test over here. What I'll do is I'll just copy this code, paste it out in these places, paste it out at these places, and that should be giving me the solution for. See, we have almost the same solution what I have over here. So if your solution lies somewhere over here, then you have done and followed out exactly uh, the steps that have been mentioned. And also you can also improve your model. Try out lasso regression, ridge regression. Okay, read about them. Try to execute them. The execution is quite easy. Okay, we just have that minimization term. It's almost similar to a linear regression, whatever we have in the regression formula, just that we have a minimization term over here. And let's plot a scatter plot for this also. Scatter plot, we are going to pass x test, and then see, this is what we are getting as the solution. This is for the training set and this is for the test set. Okay, and again if you want to make more sense to it, just add a label for the label. This is for training set. Oops, plt.title. Yeah, and then you can do just plt.x label. Let's pass in x we had y train, and then at y label we have the prediction, the predicted price, right? Predicted value. So I hope all of these are making sense now. Let's copy the same thing, paste it out over here, change this to test set, and rather than writing y train, let's write y test. See, this is what we are getting. So that's everything about this project. Now there's one more catch over here. If you change the value over here, like we had taken 2, so if you change the value of test site, we might get a bit of different values. So if you see for in the training set, now we are getting 0.88, okay, which is quite larger. Okay, and again over here we are getting 0.84. Okay, that is, I'm just comparing the R square. You can check out the mean absolute error and other stuff. Okay, so as the data set is very small, so we have used only 2% of our 20% of our data as a test set. If you increase the test set, the training set all will always decrease, and our model will not be able to generalize well. So that's one thing that you should be thinking about when you are training a model. We will be needing a bit of data. That's it. I hope you enjoyed the video. Okay, enjoyed this project. I hope you guys are making more progress on regression now. We will connect again in our next section once we start with the classification model. And just before ending this, we have one more data set, that is the bike data. Okay, we have something similar over here. Okay, quite the similar stuff that we have: selling price, year, seller type, owner, kilometers driven, and x showroom price. So it will be really nice if you guys practice it out. Okay, you have to apply the same thing over here. Whatever we have done in this card data model, you have to do the same thing for this bike data model. Okay, try it out. It will be a very good practice and very good exercise for you. So that's it for this video. We'll connect again in our next video. Thank you very much.